Hello dear students. After learning definition of Turing machine, let's see working of Turing machine. Now recall in the previous video we saw Turing machine is a 7-tuple and we just described what these 7 things are. But more amount of understanding will be done in this video on working of Turing machine. Now you just see these 5 lines that I have written. These 2 and these 3 summarizes working of PDA. Now how exactly and what it means here is, just see, at any step, at any step, Turing machine is in some state Qi, obvious. Even when Turing machine starts, it is in Q0 state. So you can't deny the fact that at any point of time, Turing machine is in some state Qi, correct? And the second thing is, Turing machine is reading some input symbol, say A. Any input symbol, we have denoted that input symbol as A from the tape. Just recall, at any point of time, the Turing machine will read some input symbol from the tape, correct? Yes. So Turing machine is doing these 2 things at the moment. It is in some state, okay, and it is reading some input symbol. Now, what will this result in? These 2 things you watch will result in 3 things, as I have written below. Yes, now you come to this point, the definition that we saw in the previous video. Watch very carefully. 2 things are written on the left here, will result in 3 things. Please try to understand what I am doing. You may say, sir, we are learning working of Turing machine, but actually we are learning delta function, because delta function itself describes working of Turing machine. Okay, coming back to this, Turing machine is in some state Qi and it is reading some input symbol A. Then it may result in Turing machine may or may not change the state. That depends on our design or our requirement. So if it is in Qi state, then Turing machine may remain in Qi state. That means there will be a loop, Qi to Qi. But maybe Turing machine will decide that it will change the state from Qi to Qj. So it may or may not change the state. The second thing is, Turing machine may or may not write new symbol on the tape. That means suppose it has just now read A as the input, in the state Q0. It is in the state Q0. This is how we show that machine is in Q0 state and it is reading A. Then it may override this A with X, some new symbol, or in Q0 when it is reading A, it may keep this A as it is and just shift ahead. Correct? Now, whether to override this or not depends on our application, depends on our problem, but both options are open. As a designer of Turing machine, you may write new symbol or you may keep the symbol as it is. And the third thing is, Turing machine may move the head to the right or to the left or keep the tape stationed. Recall that the tape can be moved right or left, or you may take a decision, I don't want to move the tape. So the head should be at the same symbol which it was reading last time. 2 things have resulted in 3 things. Have patience. Just check. Trust me. This is so simple if you learn something with me called instantaneous description. Instantaneous description. Just imagine Turing machine is in Q0 state right now. So I have shown Q0 and in this state it is reading A. Okay, input A. And imagine that Turing machine decides to change the state to Q1. Look how from Q0 Turing machine has entered Q1 state. And it has decided that this A, this symbol A which it read should be overwritten as X. Okay. And it has also decided that this head should be moved one place to the right. So you can see that the head was actually at this particular symbol, which has been overwritten from A to X, and that head has moved one place to the right. So what was the first thing? Turing machine is in state Q0. Second thing, Turing machine reads A. What is the result? First thing, Turing machine changes the state to Q1. Second thing, Turing machine writes X on top of A. That means it has overwritten the letter which it read A as X. And the third thing is Turing machine moves the head to the right. Are you understanding that this is nothing but delta function that we are describing here? Q cross tape symbol. This symbol is tape symbol, results in Q cross tape symbol cross L or R or S. How do you understand this now? Just check. Just check. If I write Q0 comma A, Q0 comma A, tell me, isn't Q0 member of Q? Yes, it is one of the states. And A is a member of tape symbol. Come on, A is coded on the tape. So this set, recall this is a set, contains A. So Q0 is element of Q, A is element of this tape symbol. You can say that this is the delta function. Okay, but what does it result in? It results in going to Q1 state. We are entering Q1 state, and this letter A has been overwritten as X, and the head has been moved to the right. So isn't this Q1 member of Q, X member of tape symbol, and this R belongs to this particular options? Okay, so come again. At any point of time, Turing machine is in some state and it is reading some input. Then Turing machine may or may not change the state. Second, Turing machine may or may not override that input symbol with new symbol. Third thing, Turing machine may move the head to the right or to the left or decide that the head should not be moved. Continue discussing with me. Here we go. Imagine that currently we have this configuration on the Turing machine. Please help yourselves over here. This is the configuration currently. And it results in, look what decision Turing machine has taken. It results in following thing. Just check. Just have a look at this. What really has happened? Just try to put it in words. Machine was in Q1 state, correct? And it was reading input A, correct? So this is Q cross tape symbol. But what did it result in? Machine remained in Q1 state. Look at the decision made. And this symbol A, which it read, was not changed at all. It was left out as A itself. So the A which was read from the tape was kept as A. The third thing is that clearly this head has moved to the next letter. You can watch here, it is at B. So this is comma R. This is clearly Q, comma, tape symbol, comma, L or R or S, but this belongs to R. This is the delta function. So delta function decides that when the machine is in some state and when it is reading some input, then what are the actions to be taken? Three actions will be taken as you are seeing on the right hand side of the arrow written over here. Keep checking this with me. The instantaneous description. Now imagine that we say that current configuration is like this. This is the current configuration. And this results in a new configuration. That is how Turing machine acts for this input configuration. You just check this. Oh, I think I made a mistake in earlier diagram. Anyway, let it be. what it does, you just check the action taken by the Turing machine. Just see this. How do you describe this? Machine was in Q1 state, it was reading B. What it did? That B, first of all, machine entered Q2 state, so it has changed the state. And by the way, if you are thinking why we are changing the state, why we are overwriting B with Y, hello, don't think about it. I am explaining how to read this configuration. You will know why we are overwriting Y, why we are changing the state only when we see a particular example of Turing machine. But are you able to read these configurations and put it in the delta form? Is what I am teaching. So from Q1 we have gone to Q2 state, and what we did is that B has been overwritten as Y, and also the tape or the head has moved to the right. I hope you have understood enough, much about the configuration. Final drill, let's do just for fun. Let's say that the input configuration is like this, and currently maybe we are here at in Q3 state, and just check what has been done is, let's say, what has been done is that we have moved back and we are in Q2 state. How do you describe this? Okay, you may describe this as Q3 has read C, but this resulted in going to Q2, changing the state and keeping that C as C. You can see that C was not changed, it was kept as it is, but the head was moved to the left. Clearly the head was moved to the left, and we are back to the previous character. Okay, what if I say that this C was overwritten with Z? How will you now change this? Q3 was reading C, again Q3 was reading C. It changed to Q2 state. Turing machine changed to Q2 state, but C was overwritten with Z, and that the head moved to the left. So this is clearly describing delta function, and it can be Q cross tape symbol maps to Q cross tape symbol cross L or R or S. Okay. Finally, what will you say about this input configuration and output configuration? Let's say I have A, B, B, C, C surrounded by blanks. And imagine we are at this blank now, and we are in Q4 state. And this results in the configuration like this. Just check. How will you describe this? Q4 was reading B, blank symbol. This resulted in going to Q5 state, but keeping that blank as blank. See, we have not overwritten blank with anything. But you also see that the head absolutely did not move. Turing machine decided that head should be kept stationed, so last is S over here. This is the delta. So recall from the basic definition, everything was so easy. Set of states, set of input symbols. To some extent you can understand finite tape symbols also. Q0 is so simple, initial state. F is understood, F is the final state. We will show this as double circle. B is the blank symbol. Only thing that you should spend time on, and very important, is delta, for which we have spent around 14 to 15 minutes. And you should fully agree that you have understood working of Turing machine. When we return in the next video, we will see a very important example and interesting example of Turing machine. In fact, I will teach how to construct a complete Turing machine. Thank you very much.